Hello and welcome back to the course on Tableau. In today's tutorial, we will look at what spatial files are and how we are able to connect to them in Tableau. Chances are that you are not an expert. If you are, feel free to take a short break, sit back and enjoy the presentation. Now, the idea of this tutorial is not to make you an expert on spatial files, but at least to be able to know your way around the different types and how to use them. Now, Tableau allows us to connect to 4 different types. The first being shape files. We also have map info tables, keyhole markup language or KML, and the GeoJSON file. Let's have a closer look at shapefiles, however. Now, shapefiles was developed by the Environmental System Resource Institute and is one of the more widely used types. Within shapefiles, we have a few mandatory files that needs to be included in the package. Firstly, we've got the SHP file, which is the shape format, the SHX, your shape index format, and your DBF file, which is your attribute format. Now, we don't need to know the details of these fields or these files, but at least be aware that all 3 of these needs to be present in our structure or in our folder to be able to use it within Tableau. Now, there might also be some additional information that is supplied with the file, and it can be any of these file types in there, but as a minimum, be sure that all 3 of those files are required to be used within Tableau. Now, we have a similar pattern on the map info tables where we have 4 different file types which are required. There are also a couple of alternative files, and for KML and GeoJSON, we just have 1 required file type to be able to use this within Tableau. Now, working with maps in Tableau, we know there are 3 different types, and some of these might seem familiar from earlier on in the course. The first type is the polygon map, which is also referred to as the filled map, where we have polygons depicting the shape or the outline of a specific area on the map. And then we can use our dimensions and measures to color the whole polygon. Then we also have a point map, where we actually use the latitude and longitude points within a map to point out where certain things are located, and we can enrich that obviously with our dimensions and measures in terms of color and sizing and a few other attributes. Lastly, we have the line map, which connects different points on your map to be able to show direction or actual distances between points on your map. Now, we also know that Tableau has some built-in geographic roles that we can work with within Tableau, and we can define these as city, country, or state zip codes as well. We even have airports and some other area codes that we can use, but these are also quite limiting. And there might also be the occasional time when you might need to use geographic roles outside of what's available within Tableau. Examples of these might be school districts, dams, or parks where we need that additional spatial data. Now, from Tableau 10.2 onwards, Tableau has made it possible for us to connect directly to custom spatial files to draw these shapes out on the maps, but these are obviously limited to the 4 types which we have just referred to. So how does this work? Oh, it's very easy. You just need to obtain the spatial files from an authority or an open data platform, and this could also be from some of your cities or local government institutions that generally supply a vast number of these different shape files. And what we need to ensure though is that we do have the required fields for the types that are being supplied. So once we are connecting to this, Tableau will then analyze the files and make the files available to be used within Tableau. Tableau basically transforms the files using the latitude and longitude information and creates a very important new field which we haven't seen before, is the geometry field. And the geometry field basically acts as an alias for the underlying data that is able to draw the lines or points or polygons even on our maps. So generally, the shapefiles that are supplied by these institutions also contain additional information. So when you are looking for specific data, also have a look when you connect to the spatial files, what else is available in there for analysis before searching for it on any other platform. Now, the data that we are looking at for this specific case was obtained from the New York City Open Data Platform. And if I just open up the folder, you'll see that we have 4 files in there. Firstly, we have the DBF file, the shape file, and the SHX file. Lastly, we also have the PRJ, which is additional information, but as we know, we at least have the 3 mandatory files that we need to use the spatial files, or rather the shape files for this specific format. But let's open Tableau and see how it works in practice. So we'll start off by adding a new data source. And again, we just look at our data source types and we can just select the spatial file. When we when we navigate to our folder, we'll see that Tableau is only looking, well, it looks for the couple of types there, but we have the shapefile and that's what we'll select to connect there. And immediately Tableau connects to it and draws through all of the information that's contained within these files. So what's important for us is, in this specific case, will be the name field, or the name 311, which we'll rename a bit later, the borough in which it is. If you think back to the case study, we need to do something with the borough, and lastly the geometry. So there'll be some cleanup necessary here, but this is the important field that we spoke about that contains, and we know what kind of shape or what kind of point will be drawn, and we know that this is the alias that connects it to the information in the background to know how to draw this, the latitude and longitude, because you'll notice that all that information is not captured in here. All right, just to see what it looks like, we'll just open up a new sheet, go and look for the geometry measure over there. Once you drag that into your map, immediately it draws all of the different parks as one object, by the way. So let's quickly put in the name into detail to make them individual. There we go. And you can see all of the different parks and public spaces within New York. It will be drawing, and you can see their Central Park, which we need to exclude for our case study, and all of them. And if you scroll in as well, you can see how the shapes are exactly the same as the actual parks within this city. So quite a lot of public spaces and public parks within New York City. And that was it for this lecture. In the next tutorial, we'll be connecting the spatial files to our PDF data in preparation to solve the business challenge, inching our way forward to the final result. I look forward to seeing you the next time. Until then, happy analyzing.